Hello guys, hope you are doing well. In this video for lecture 6 I'm going to talk about linear programming. I spoke to some of you and I learned that the linear programming is really new to you. So I'm gonna try to explain it in as easy as possible, but I can assure you that linear programming is really easy. So let's dig into it. Let's just cover a bit of theory when it comes to the linear programming. So why do we need it? Why do we use linear programming? We use it to find minimum and maximum values of the functions. And there are two things we need to bear in mind. So first thing, x is always positive, and second thing, the y is always positive. By meaning it will be greater or equal than 0. So it still can be 0, right? But it will not be positive. So also when we draw on our graph, it will go somewhere in this quadrant. And there are two ways to solve the linear programming exercise. In this video, I'm going to focus on the graphical method for two reasons. First reason is it's the method that we covered in class. And second reason, that method is like 100 times easier than the other method, which is called table method. So how do we approach graphical method? First, we draw the function. Second, we shade the area on the graph for which our answers would be true. We identify the corners and find their coordinates, and then we just evaluate which one would be the minimum or maximum depending what we're asked, and we give the most suitable answer. So what does this mean? This is really not hard, and we're gonna go straight into example so that I actually can show you how to do it, and then you will hopefully realize that it's really easy. The example that I'm going to use is the example I found online, so this is not on our sheet or document, so don't look for it there, you will not find it. But it goes like this. Two types of animal feed are used for animal nutrition, so A and B. 1 kilogram of feed A contains 100 grams of fat, 200 grams of proteins, and 600 grams of carbs, and costs $3.5. 1 kilogram of feed B contains 50 grams of fat, 300 grams of proteins, and 450 grams of carbs, and costs $4. Every animal must consume on a daily basis at least 60 grams of fat, 180 grams of proteins, and 450 grams of carbs. How much of each feed should be given to the animal on a daily basis so that their nutrition needs are satisfied and costs are minimal? So let's take a look and let's actually highlight what's important for us. Okay, so first there are two types of feed, A and B. Okay, we know that 1 kilogram of feed A contains 100 grams of fat, 200 grams of proteins, and 600 grams of carbs, and costs $3.5. Okay, the second feed B contains 50 grams of fat, we're gonna color it, 300 grams of proteins, this color, and 450 grams of carbs, and it costs $4. Okay, every animal must consume on a daily basis at least, so that tells us the sign that we're gonna have, right? At least, let's color it green, 60 grams of fat, 180 grams of proteins, and 450 grams of carbs. So let's color it blue. And now the question is, how much of each feed should be given to the animals on a daily basis so that their nutrition needs are satisfied and costs are minimal? Okay, let's use this color. Okay, so let's write like this first. Let's say that X is daily intake of feed A and Y is daily intake of feed B. We know that both Y and X must be either 2 or greater, so they will not be negative. And knowing that, we're going to write our equations. So for the fat, we have 100 grams of fat, 50 grams of fat, so 100 for A, 50 for B, and we know that every animal should eat at least 60 grams of fat. So what would it look like? 100x plus 50y to be greater or equal to 60. Same we will do for proteins. We will have 200x plus 300y to be greater or equal than 180, and carbs 600x plus 450y to be equals or greater than 450. So these are pretty big numbers, right? And we can always simplify them. So what we're gonna do, we're gonna divide the first one by 10 so that we have 10x plus 5y to be greater or equal to 6. Second one, we're gonna divide by 20, so we have 10x plus 15y to be greater or equal to 9. And the third one, we're gonna divide by 150 so that we have 4x plus 3y to be bigger or equal to 3. You don't have to do that, but I like to have the smallest possible numbers while doing equations and linear programming in general. And what is the question? So first, how much of each feed should be given to the animals on a daily basis? So calculate x and y, and the costs are minimal. And the costs for 1 kilogram of feed A is 3.5, and the cost for 1 kilogram of feed B is 4. So we're going to write it as C of x and y will be equal 3.5x plus 4y to be our minimum. Okay, now knowing this information, we can easily graph them, right? And our graphs will look somehow like this. So for the first graph of 10x plus 5y to be greater or equal to 6, this would be our line, and this shaded area is the entire area for which our solution would be acceptable, would be correct, okay? So this is the entire area. Then the same thing we would do for the second linear equation. So we draw a line, and this is the entire shaded area for which it's correct. And the same thing for third one. Here is the line, and here is the shaded area. So now, knowing this one, we need to find the area for which all of these three functions would be shaded, which means, so what is the area where all of these three colors are visible, right? And this will be somewhere between these, right? So let's take a look at the following one. Okay, so this will be our area for which all our x and y answers would be correct. And now we need to find the corners of it, and we would get corners by looking at the places where our functions intercept. So we have intersection of first and third function in point 0.3 and 0.6, and our second and third function in 0.6 and 0.2. So these would be two coordinates we actually want to check, and we want to focus on them. So now what we're going to do, we're going to come back to our cost function. C of x y equals 3.5x plus 4y to find minimum price, and we're going to just substitute x and y with the coordinates of these 2 points. So for the first one, let me actually use different colors so that you guys don't confuse it. Okay, so C for 0.3 and 0.6, which is just this coordinate here, we would get, okay, C of 0.3, sorry, and 0.6 will be equals 3.5 times 0.3 plus 4 times 0.6, and the answer will be $3.45. So that means that the cost for daily intake of 0.3 grams of feed A and 0.6 grams of Y feed will give us $3.45. And now let's take a look at the second coordinate, and actually second point, and the coordinates are 0.6 and 0.2. So 3.5 times 0.6 plus 4 times 0.2 would give us $2.9, meaning that for a daily intake of feed A in kilograms would be 0.6, and for the daily intake of second feed in kilograms, 0.2 kilograms, would give us would cost us $2.9. And when we compare these two, we see that 2.9 is smaller, or actually cheaper, than $3.45. So we would say that C's minimum for 0.3 grams of daily intake of feed A and 0.2 grams of daily intake of feed B, and that would be our answer. Guys, when it comes to this one, I really have nothing else to say. This is really easy. I hope that you now have some sort of an idea what linear programming is and what it means. So, if you have any questions regarding this, please contact me. Practice this. This is, in my opinion, one of the easiest things we've covered so far in our lectures. I will publish the next video in 7 to 8 days. So by that time, just practice what we've covered and contact me if there are any questions. Other than that, have a good day and see you soon.